Hey everyone, and welcome to Modern Tech Creators. Have you ever typed out some code and just wondered how in the world your computer actually understands it? I mean, computers only speak in ones and zeros, right? Well, it's all thanks to some really clever translators working behind the scenes. And today, we're going to break down the two big ones, the compiler and the interpreter.
So here's our game plan. We'll start with the basic problem they're trying to solve. Then we'll meet our two translators and use a really simple analogy to get the main idea down. From there, we'll look at how they actually work, check out which programming languages use them, and finally, answer the big question: which one is better?
All right, so first things first, we need to understand the core challenge here, which is basically a giant language barrier between you and your computer. I mean, really think about it. We write code using things that look like English words, right? With symbols and a structure that makes sense to us. We call this a high-level language. But computers, yeah, they don't get any of that. They only speak machine code, just a long stream of ones and zeros. So how do we possibly get them on the same page?
Well, that's where a translator comes in. We need a special program that can take the source code we write and turn it into the machine code the computer's processor can actually understand and execute. And that's exactly what compilers and interpreters are built to do.
Okay, so it's time to properly meet our two translators. You can almost think of them as having totally different personalities, even though they're both trying to accomplish the same thing.
First up is the compiler. The compiler is like a super thorough planner. It takes your entire program, reads the whole thing from top to bottom, and translates it all at once into a brand new standalone file. This file is often called an executable. All of this translation work happens up front, before you even try to run your program.
And then you have the interpreter. The interpreter is totally different. It's much more of a do-it-as-you-go kind of translator. It doesn't bother looking at the whole program ahead of time. Instead, it reads one line of your code, translates it, runs it, and only then does it move on to the next line. It's all happening live in real time.
Okay, those definitions are fine, but let's use a simple real-world analogy to make this difference really clear.
This analogy just nails it. A compiler is like a book translator. They take the entire book, spend a bunch of time translating every single page, and then hand you a completely finished, translated copy you can read whenever you want. The interpreter, on the other hand, is like a live translator for a conversation. They translate sentence by sentence, right on the spot, allowing two people to talk back and forth in real time.
All right, now that we've got that book translator versus live interpreter idea in our heads, let's get a little more technical and see what the step-by-step process looks like for each.
With a compiler, it's a very clear, multi-stage process. You write your source code, you feed the whole thing to the compiler, and it chews on it for a bit. If everything looks good, it spits out a completely new file, the executable machine code. Then you run that file. Notice, the original source code isn't even needed at runtime.
The interpreter's process is way more direct. It's basically a loop. It takes your source code, reads line 1, translates, and runs it. Then reads line 2, translates, and runs it. It just keeps doing this over and over until it hits the end of the file or finds an error. There's no separate compile step and run step. It's all happening at the same time.
And these different approaches create a huge trade-off in speed. You can think of it like the tortoise and the hare. The compiler is the tortoise. It has that slow start because it has to translate everything first. But once it's done, that final executable program runs blazing fast. The interpreter is the hare. It starts running your code instantly, which feels great, but its overall speed is slower because it has to keep stopping to translate every single line as it goes.
How they handle errors is also a night and day difference. A compiler acts like a proofreader. It reads your entire program and then comes back with a list of every single mistake it found. You have to fix them all before it will even create the executable file. An interpreter, though, will run your code happily until it hits the very first error, and then it just stops dead in its tracks and tells you exactly what went wrong on that one line.
So let's just pull this all together. As you can see, the compiler translates everything at once, which gives you a faster final program and a standalone executable file you can share. The interpreter translates line by line, which is a bit slower and doesn't produce an executable, but it's often way easier for debugging since it stops at the very first problem.
Okay, this is all great in theory, but where do you actually see these approaches used? Let's look at some popular programming languages you might know.
So languages like C, C++, Rust, and Swift are classic examples of compiled languages. And this makes total sense, right? These are the languages used to build things where performance is absolutely everything, like video game engines, operating systems, and really complex software. You need that raw speed.
On the other side, you've got languages like Python, JavaScript, and Ruby, which are typically interpreted. And again, this fits perfectly with what they're used for: web development, data analysis, and scripting. In these areas, being able to develop quickly and run your code on any machine without a hassle is way more important than pure execution speed.
Now, just to make things a little more interesting, the line can get pretty blurry in the modern world. A lot of languages, like Java and even Python, actually use a clever hybrid model. They compile your code first, but not all the way down to machine code. They compile it to an intermediate language called bytecode. Then, a special interpreter program, called a virtual machine, runs that bytecode. It's a way to get the best of both worlds.
So all of this leads us to the ultimate question. After all the pros and cons, which one of these is actually better?
So when it comes down to it, who's the winner in the battle of compiler versus interpreter?
And the real answer is neither of them. It's not about one being better than the other. It's about using the right tool for the right job. It's a classic trade-off. If your number one goal is maximum performance, a compiler is your friend. If your goal is to develop quickly and have your code be flexible, an interpreter is probably the way to go.
So let's recap one last time. The compiler translates everything up front to create a fast, optimized executable. The interpreter translates as it goes, line by line, which is great for flexibility. Just remember the analogy: book translator versus live interpreter. The final choice always boils down to one thing: speed versus flexibility.
And that is the core difference. I really hope this helped clear things up for you. If it did, do me a favor and hit that subscribe button for Modern Tech Creators. We have a ton more tutorials and explainers just like this one coming your way. Thanks for watching.